Hello, this is Lillian from Cover Java for Cover Java Cup 2 Week 1. So let's get started. A lot of this class is going to be welcome and introducing things, so we'll skip over that and we'll just quickly get into the actual content. I think I said this in one of the other videos, but we decided to film videos for the classes, so if you guys missed the class or if anyone else wants to just watch them to learn how to code, we would have them available. So yeah, let's get started. And Cup 2 is our program for coders who know a little bit more of the basics, or maybe they're transferring from another language and they already know how to do the basics of coding. And they're just switching over to Java to learn more of the structured stuff like classes, methods, that type of thing. Objects, constructors, those types of things. So yeah, we're just gonna get right into it. And the first class is a lot of review. It'll give you a lot of time. Gave them a lot of time to work on a project. So yeah. First of all, hello, welcome, and yeah, we'll be skipping over the stuff, but you can definitely look at the slideshow and uh, do this stuff if you think it's interesting because it's all available. So first, we need a programming software. So if you guys are using other languages that are maybe specific to another programming language, for example, PyCharm for Python or something like that, you need a program to do Java in. So the options are, there's obviously more than what you're doing here, but yeah. Um, you can use Eclipse, which is a really common one. There's also IntelliJ, Visual Studio Code, and Replit, which is for online collaboration. You just go to repl.it is a website, and you can create an account and make programs. So yeah, we're not going to go over specifics of how to make the programs and what really programming software is, but if you want, you can look at that section in Cup 1, Week 1. So yeah. So what should you know? So for this course, you should know the basic Java, but we will be reviewing this in a second. So don't feel too stressed about it if you think you're a little fuzzy on the details. So this includes print statements, variables, computations, which is like plus, minus, divide, mod, stuff like that. If slash else if slash else statements, iteration, and user input, as well as basic conventions like when to use semicolons, um, uh, when to use semicolons always, when to use braces and stuff like that, which you should know if you do if you know if slash else if or iteration. But yeah. So first, if you guys just want to work on the project and just end the video here, I was just gonna explain the project and then you can just go work on it. This is basically a quick review project, so you guys can familiarize yourself back with um, the basic Java we showed on the last slide. So here's the project. Please create a bakery, or a virtual bakery if you will. So print out at least 5 options for the user to choose from. Take input on which one they would like, and depending on their choice, add to their total price. Um, After the selection, ask again if they would like to continue shopping, and just keep asking them until they say no. After they say no, let them enter how much they would like to pay. So you should print out their total price and include the tax rate in Maryland, which is 6%, and let them enter in how much they'd like to pay. If they paid more than the total price or they pay equal to the total price, just return them the change and wish them a nice day. And if they don't pay enough, please ask them kindly again to keep entering payment until they pay enough. So here's a quick example of the project sample outputs. As you can see at the top, we printed out the 5 items with the corresponding prices. Welcome to Cup of Java Bakery. You can choose between red velvet cupcakes, caramel-filled cupcakes, strawberry shortcake, Oreo macarons, or just the baguette, which is $3.99. Very fair price. So as you can see here, we asked the user what they like to order and asked them to enter the corresponding number of the order just for simplicity, and they choose one. So that's red velvet cupcakes. So that their total price should go up by $4.99, which when you print out their total price, it is $4.99. And then we ask them if they would like to continue shopping. If yes, enter 1. If no, enter 0. So they want to continue shopping, so they enter 1. And they ask, what would you like to order? Again, it loops back to here. the first question we ask them. And this time they want to order caramel-filled cupcakes, which are $5.99. So we add that to their previous price of $4.99 to get $10.98. And we keep asking them if they like to continue shopping. Yes, 3, and then you add that to their price, which was the cake, right? Yeah, so that's much more expensive now, you can see. But essentially the price adds as it is when you're shopping for multiple items. And you see after they don't want to continue shopping anymore, it prints out their total price for a shopping trip, including tax, which is 27.5282. And if you guys want, you can round this off at 2 decimal points. I just decided to leave it like this because I was running short on time. But yeah, it's pretty easy to truncate it 2 decimal points if you just want to search online. That shouldn't be too bad. And you can see here that I want to pay $25, but the total price is 27. So the program prompts me that my payment was not enough, and they want me to enter this much more money to leave with my items. So then I say I want to pay $3, and then it thanks me for shopping with them, and it gives me the change because this is how much they returned because I paid. This was how much I owed. This is how much I paid. So they returned that amount of money, and then they asked me to please come again. So yeah, that's basically what the sample project is, and if you guys just want to work on it now, that'd be great. I think it's pretty fun, and I had a entertaining time writing it. It's not too complicated, but yeah, pretty simple overall. Let's get into review now. If you guys, yeah, want a quick review of these things. So I think, yeah, let's start with print statements. Or, sorry, yeah, let's start with variables. Sorry about that. So examples. Variables always follow a standard convention, which is the variable type, the variable name, is equal to the value of the variable. So in Java, which is different from, I think, Python in this way, you need to declare the type of the variable while you're defining it, because the way Java does like storage and allocation of certain space in the memory. Sorry. Basically, certain data types need more space than others. So when you define a variable, you have to tell the computer what variable type it is so that it knows how much space to use to allocate to that variable. So for ints, you can see you have the keyword int for integers, and integers are just essentially whole numbers, including negative numbers. So basically, just the standard math definition of integers. um, Doubles, which are just vari variables of numbers with decimal points, booleans, which are just true and false, and string examples, which are just like sentences or words. And remember that you have to write the variable type in the ways that are written here. So int is int all lowercase, double is double all lowercase, boolean is written like this, all lowercase, and string is written with a capital S, which you might learn in this class, one of the future videos, why. But yeah, and for string, remember that you need to add quotations around whatever the string definition is to indicate that it is indeed a string. Okay, so let's move on to print statements. So print statements are pretty simple. They're basically the first thing you learn in every coding class. And essentially, the way to do print statements in Java is system.out.print hi. And hi is in quotations, obviously because it's a string. Um, so, but in Java, there's like multiple types of print statements, but these are the main two you probably will encounter. So print does not, after you do that line, it doesn't automatically move the next print statement to the next line, which is a little annoying. So they've made system.out.println or println, which automatically moves the cursor to a new line. Essentially, if you did two print statements right after the other, where you did this print statement and then you did this print statement, it would just print out hi, and then right after that on the same line, it would print out hi, which was this print statement. And then if you did another print statement after this, it would go to the next line automatically because .println moves the cursor to the next line. Okay, so now practice for combining integers and print statements. So in this print statement, we're doing system.out.println, parentheses, x plus quotations, and quotations, plus y plus quotations is plus parentheses x plus y. So as we can see from our variable definitions here, which we learned about in the last slide, these are int variable definitions, and x is equal to 3 and y is equal to 5. So it would say 3 plus 3 and 5 is, and then print out the value for 3 plus 5, which is 8. So this should print out 3 and 5 is 8. And the plus sign is just how you combine different variables and strings in the print statement, which is concatenation. And in the second one example here, you can see that we didn't put parentheses around the x and y. So what would be the problem here? Because we didn't put print statements onto the x and y, and because this is adding on to is, which is defined as a string, it adds weirdly. So essentially in Java, it's assuming that what you print in the line is going to print it out as string because that's how they want the user to see the output data as a string, because that's what you want, how you read it. So if you assume this is a string, we assume that it's 3 plus 5. 3 plus 5 is, and then it's because you're adding on to the string, it's just going to say 35. Versus this one, we put parentheses to indicate that we need to do this first, and because these are both int values, the program knows that you want to add those numbers. But in this one, they don't know that because in order operations, they do is plus x first, not x plus y first. So they just assume that x is a string and add it on, and then they add y onto that string. So it would print out 3 and 5 is 35, which is not correct. So yeah, make sure that's a pretty common error, I think, for a lot of beginner coders. So always remember order operations and keep in mind how print statements work. Okay, quick review of imports and inputs. So importing is essentially something you do when you want to use code that is so common that a lot of people have already written it, and you don't want to write it yourself because it's just too tedious and it's too time consuming and it takes too much space basically. So this is when we import libraries, and libraries are just code that other people have written, putting on a very, very basic level. And Java has a lot of libraries which you can find online, but the Java.util library has a lot of essential functions that a lot of coders need, including the java.util.scanner, which is what we use to do user inputs. So after you import the java.util.scanner thing at the very top of your code, you need to create a scanner object, and you'll learn what this actually means later in the class, but for now just like trust me and just type this line of code in. So type the line scanner input is equal to new scanner parentheses system.in. So essentially this is kind of just like when we put a int object. You can think of it like that. Int variable. You can think of it like that. So in this one, we define it as an int, right? This is the variable name, and this is what the variable type is. So in this one, we're defining a variable called input that type is scanner, which is like kind of confusing, but you'll learn how to make your own variable types, I guess, in the future of this class. It should be fun. And yeah, so to create it, you do scanner input equal new scanner system.in, and yeah, because it's input, because the name of the variable is input, we can reference it later. And to get user input, we have a you first use a print statement to ask the question, and then you use one of these lines to take in what the user types after that statement and assign it to a variable. So you can use that variable later, like you use normal variables, except now the value assigned to it is the value that the user gave it when it answered the question. So for different types, you obviously have to use different statements. So for doubles, you assign the variable as a double, obviously, and then you do equals input, which is name of the scanner, and you can name this whatever you want. So if you name something different here, just remember to use the same thing here. And dot next double, because this is a double variable, and then do parentheses, and then semicolon, obviously, semicolon. And for int, you use dot next int, and for string, you do dot next line. So remember that these vary based on type, and that's something you should probably remember. So yeah. After that, you can just use them whatever you want, just like normal variables. Let's move on. Oh yeah, here's a quick excerpt from actual code that shows where to put it. So even above your class and your public static void statement, add your import statement for java.util.scanner, and then here's where you define the scanner variable, and I called it user input, and I said equal new scanner system.in, and then I printed the question here, and then in my code it would, and then I use this line so that in the code it would ask for that, and whatever the user type would be assigned to this variable user choice, which I use later to get their choice basically. And remember, I use next int because it's an int variable. So there's essentially only three things you need to remember: import the scanner, create the scanner, use the scanner. Okay, quick review of computations. So computations are basically just math. It's not that complicated really. That's why this slide is so barren, I guess. So the plus sign is add, the minus sign is minus, the slash is divide, the asterisk is multiply, and the percentage sign is mod. So essentially, the mod is I don't think it's as learned in schools as the other signs, as other operations, obviously, but it's pretty useful. Essentially, it's like a remainder when you divide. So you might have learned when you divide variables that aren't cleanly, you get a remainder, right? So if you divide 30, 33 by 2, you get 16, 33, yes, yeah, 16, remainder 1. And then mod essentially just returns the 1 because that's the remainder. A lot of times mod is used to check for if variables are even or odd, because you can just mod anything and see if the remainder is either 1 or mod anything by 2, and you can see if the remainder is 0 or 1. And then if it's 0, obviously it's even. If it's 1, then it's odd. So yeah, that's what mod is used for. You can also use it a lot of different ways, but yeah, you'll discover its uses in your own time. That's it for computations. Let's move on. So if statements. If statements are conditionals, essentially. So when you want to run a part of code, but you only want to write it if a certain statement is true, you use if statements. And if statement, the format for writing if statements is the keyword if, parentheses, and you put a condition in the parentheses, and then you use the curly braces. And inside the curly braces, you write the code that you want to run if the condition is true. So the condition is usually going to turn into a Boolean value, right? So you want to check if two things are equal to each other, or if something is true or false. So you can do this in a number of ways depending on what you're trying to compare to each other. If you're comparing if two strings are equal, you use the string one dot equals string two, and then if whatever you assign to string one is a variable and string two is a variable, by the way. Whatever you assign to string one is equal to string two, like character for character, then that would be true. So then it would go inside the if statement and execute whatever code you want to do. For int or doubles, you can just use two equal signs, and that's basically equivalence, and that's basically equivalence. So you can just check if they're equal like that. And you can also replace equal to other things, such as uh, greater than or equal, less than or equal, greater than, less than. This exclamation mark equal is equal to not equal. In Java, if you want to say not, you can just use the exclamation mark, and that basically represents not. So yeah, remember that you can always use, for numbers at least, it's just pretty easy to just use these normal conventional signs to check if two ints or doubles are the relationship to each other, essentially. And finally, they're just Boolean. And if you just want to assign a variable to, if you want to assign a Boolean variable true or false and just always make it run, or for some reason like do it like this, or you can just say if true and it'll just run. And yeah, thinking off the top of the head, there's not really many practical applications for this, but if you think about it, technically all these statements are Boolean variables in a kind of I don't know, if you think about it way, because if this is true, it's saying that the condition is true, and that's basically a Boolean, true or false. So yeah, besides if statements, there's also Elsif and else statements, which is like, um, they're connected to each other. So if this condition is not true, then it will, and you add a else if statement, then it will go to the else if statement and check for that condition. And if that's true, it'll do that else if statement. And you can stack these as much as you want. So you can just do like, if this is true, then do this. Else if this is true, do that. Else if that is true, do this. And if none of that is true, and you've gone through all those else if statements and if statements, then else, last case scenario, do this. So that's essentially what's the point of else if and else statements. You might be wondering like why use it, like if and else if statements when I can just use if statements. Well, if you have if statements and else if statements, it will just stop once it finds one of the conditions that is true, and then it will just skip over all the rest of the possible else if and else statements. But if you just have multiple if statements one after other, your code will check for multiple of those, and like in a way you can think about it, multiple of those if statements could be true, so it might do something that you don't want to do because you already did what you wanted to do, but then you ruined it by having another if statement which was true for it. So yeah, that's the difference between if, else if, and else statements, and also basically a quick review on when to use if and else if statements. Okay, so iteration. Iteration is really fun because this is I think the simplest thing that people get wrong. Or this is loops are always a mess for me at least when I write them. There's almost always an error. Or yeah, so make sure that you write them correctly. So we have in Java a lot of different types of, well, we have not many actually. There's like three. There's for loops, while loops, and do while loops, which there's actually more. You also have enhanced for loops, which we're not going to touch on, but yeah, for loops, while loops are basically the two we're going to be focusing on. So in for loops, you use the keyword for, parentheses, and we have three aspects or three portions of this, what's going to be in this parentheses. So the first thing is assigning a variable to a value. And this variable is usually I just because it's pretty conventional to do it, just a variable I. And then, yeah. So, and then in the next one, you're saying, this is the conditional, this middle portion, you're saying that um, while I is less than 10, keep doing this for loop. And the last one is saying, each time I run this loop, I want to add 1 to I. So yeah, that's basically how it works. And in this one, it will print I 10 times because if you think about it, it goes I is equal to 0, right? Then it prints out 0, and then it adds 1 because that's what this statement in the red is doing. It's going to add 1 each time it runs. So then go back to now I is equal to 1, and that 1 is still less than 10, right? So run again and print out 1, and then it will add 1 to I, which so is equal to 2 now, and just keep going. So in the end, it'll print out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then because after you run the 9 time, after you print out 9, I is gonna be plus 1, right? Which is equal to 10. So because 10 is not less than 10, it will quit out of the for loop. So that's how the for loop would work, essentially. And the while loops are pretty similar. They're just like a little more work on your part. So as you can see here, they're more used when you don't know how many times you want to run it before you actually run the loop. So in the for loop, while we're writing it, we know it's gonna run 10 times and then just end, right? But in the while loop, it's if we don't know how many times we want it to run before we write it, then how are we gonna write it, right? So in this example, we're taking user input of a number, and then we're gonna keep running it while that number is divisible by 3. And we're going to count the number of times that it's divisible by 3. So in this one, you can see while user input is greater than 1, we want to keep dividing it, and then once it's less than, or I don't know, equal to 1, stop. And then we get the number of times, which is how many times it's divisible by 3. And yeah, while loops and for loops are not as different as you think. You can write a while loop as a for loop, but yeah, essentially use while loops when you don't know how many times you're gonna run it. Use for loops when you do know how many times you're gonna run it while you're writing it. I remember when I was learning Python though, um, I would constantly just use while loops instead of for loops because I found while loops easier to write, which is kind of weird to think about it now. But yeah, if you really wanted to, you could use while loops as for loops. But just remember that they're not as different as you think. But choose the right one for the occasion. Yeah, that's basically all I have to say about that. And that's basically everything you need to know to write the program. Um, oh yeah, let me just quickly say something about while loops. So while loops can also be used if you want to complete it, reuse code until a user tells it to stop. So quick hint, this part where we keep asking the user if you want to order, would you like to order, would you like to continue shopping, that was a while loop. So yes, keep that in mind for when you're writing your program, if you write it. So yeah, homework, you can do this hat riddle if you want, it's pretty interesting. And also finish a project if you have time. And without further ado, I'll be reviewing the project in another video, I think, because I do have it written. I'll review it in another project though. I mean another video, sorry. And yeah, thanks for listening, and Kappa Java signing off.